Okay, now let's get this data set ready for machine learning. So what I want to do first is look at it. So type in df.info and see what I get. Just make it a little larger so y'all can see it better. There are a lot of objects. If you look at the data types here in the far right column, object, and you can see them in the code. It's pretty obvious, right? They're basically represented as strings. Whenever you see objects, you want to convert those into numerical columns, integers or floats. Doesn't really matter which. So what's the approach? Well, there's some different approaches, and we're going to use the most simple, which is called PD get dummies. Okay, fascinating name there. But before we do that, I want to highlight something important. So there are two standard different ways to convert categorical columns into numerical. Look at the education column here. See bachelor's and they're given a number 13. High school grad, number 9. 11th grade, a number 7. Education is what's called an ordinal column. It's ordered, okay? Meaning like there's a numerical sequence. So those are translated into their own numbers, and they've actually already done it for us here. So this makes the education column absolutely extraneous. It ends up being just like a key for the numerical ones. So this is one way that you can do it. I'm not going to do that here because we don't need to, but you can actually reassign it. Like imagine you just had the education column. You could reassign these to numerical values based on what they are. You could do, there are even some built-in methods that you can use with pandas and they'll create the numbers for you. But there's a second method that's used majority of the time because most categorical columns are not in fact ordinal. So if you look at working class, you could try to put these in a numerical order, but it's really superimposed, right? Like where does private fall between self-employed and state government? Or let alone occupation, you have different occupations. So the issue here is that if you just give each one a different number, mathematical models are going to consider that 3 is 2 more than 1 and 1 less than 4, but that's not the case with these columns. So the idea is to implement a technique where we create multiple columns from, say, the working class column, and each different option will have its own new column, and each row will say 1 if the column is present and 0 if it's not. Let me show you how it works in action. So I think that'll help. So first let's delete the education column. df, I start typing, notes education, not education num. Got an extra quote there. Okay, and get rid of that one. And now let me show you how to do PD get dummies. So I'm simply going to reassign the data frame to PD dot, it's get dummies. The dummies here means like a dummy variable. And I put in df again. Okay, and let's look at it. And note here that I'm reassigning the data frame to the after the get dummies operation on the data frame. All right. So if you look at it initially, you can see these were columns that showed up. But like if we look at least the first few, but if you look at working class, recall that there was a working class column, but now it's been underscored into several multiple columns. And what these show are the different categories of those columns. So some of them, there's a question mark. People cannot be classified. And note that that didn't show up as a null value here. Other people are in the federal government. Now, if you look down, there are lots of zeros, but look at working class private. We have 3 1s. So this indicates that for these 3 rows, each of these people belong to the private sector, the working class. Whereas like this person belongs to self-employed and this person state government worker. Now, when you have a value like a 1, clearly this person cannot also be a member of another one of these working classes. Like if they were given the value of 2, that would show up as its own column. So what was a categorical column has now been split into different categorical columns with clear zeros and ones, indicating 1 indicating presence and 0 indicating absence. Okay, and the underscore does that for you. Note that these 3 columns here Actually, these 4 are hyphenated, not underscored. Not easy to see, but you can easily figure that out if you look at the original data set. Now, importantly, let's look at df.info again. And when we do that, you can see now, look at this. They're all non-nulls now. And furthermore, I guess they're all non-nulls to begin with, but the D types are all numerical. Note that they converted into uint 8, which is smaller because it's just 0 or 1. It seems like there could even be a binary type for that. So it's saving less space. Now the trade-off, of course, is that you end up with a lot more columns. Now in this case, you get 94. So this is reasonable. Okay. Some data sets, they can go wild, you know. But in the world of big data, it's all about really, you could say, building the best models while taking speed into account. You know, that's something that we'll look at later in this class. But for us, 32,000 rows, 100 columns, you know, it's significant, right? It's like about 3 million entries. And it will take a little bit longer to actually run a model. But this is how you implement pd-get dummies. It's the easiest method to convert categorical into numerical columns. Later in this course, we'll look at one-hot encoding, which is very similar, and even sparse matrices. Assuming we get that far, it's definitely included in the text, but these are later chapters. So for most purposes, pd-get dummies will work. And from the df.info, I can see all columns are now numeric and non-null. So I'm ready to build a machine learning model with one catch. Okay. If you build it now, you're going to get a perfect score. And that's not necessary. Let's just say that there's something else that needs to be changed.